This video is going to go through the process of adding and subtracting rational expressions. Before we get to that, we'll do a quick recap of just the basics of adding and subtracting fractions, which you would have been introduced to back in middle school. So we'll start with, I have a couple of examples here. If I wanted to take 3/4 and add 2/3, well, adding and subtracting is a little bit more difficult because if you recall, you need to make sure you get common denominators. You can only add and subtract fractions if they have common denominators. Well, if I go to the example we've got, I have 3/4 plus 2/3. So what I have to do is figure out a number that both 4 and 3 will divide into. And that number is 12. 12 would be referred to as the least common denominator. So the way I'm going to do that is put this one over 12, put this one over 12. Now then the thought process that your brain goes through is, what would I have to multiply the number 4 by to turn it into a 12? Well, I would have to multiply it by 3. The way a fraction works, if I have some other fraction, 3/5, and I said, oh, I wonder what 3/5 is if I put it at a 10. Well, to figure that out, I'd say, well, I have to multiply the denominator by 2. Fractions remain equivalent as long as you multiply the numerator and denominator by the same number. So as long as you multiply this by 2, 6/10 would be equivalent to 3/5. It's the same thing here. I'm saying, what do I got to multiply the denominator by? 3. Whatever you multiply the denominator by, you have to multiply the numerator by the same thing. So that would be a 9/12. The denominator 3, in order for it to become a 12, you'd have to multiply by 4. That means you're going to have to multiply the numerator by the same thing. Once you have common denominators, you simply add the numerators. The denominators will remain unchanged. So it would become 17/12. That's called a mixed fraction. Sorry, that's called an improper fraction, where the numerator is bigger than the denominator. I find sometimes students are wanting to, I know it's a process they show you in middle school, they want you to change it to a mixed fraction, but there's really not much benefit in that. Just to show you, if you did, it would be 1 and 5/12. However, I would be just as content and happy if you left it like that. And this course isn't about learning how to add and subtract fractions. That's something you've done before, but we're going to do it with algebraic expressions. It's the same thing. You just need to understand that where you see numbers here, we're going to replace those with variables. What I find students get in the habit of doing is they say, oh, I know how to get common denominators. I always just multiply these two together, which worked here. And that gave me the least common denominator. However, if you go here, you could do that. You could multiply 6 and 8 together and get a common denominator, but it's not necessarily the least common denominator. So what you'll want to do here is look at the 6 and the 8, and in your head say, what would be the smallest possible number 6 and 8 would both divide evenly into? Well, you could go 6 times 8 and say 48. That is a number they both divide into, but it's not the smallest number, because 6 and 8 both divide into 24. So I'm going to put this over 24. So a really bad habit students get into with fractions is always just multiplying these two together and making it the denominator. It works to get a common denominator. It can always get you the right answer. The problem is it leads to you having to reduce. I'm going to show you what I mean by that in a second. Reduce your answer, which can be a challenge in the end. So 6 to become 24, I got to multiply by 4. That means I got to multiply the numerator by 4. I'd have 20/24. In order for 8 to become 24, I'd have to multiply by 3. I'd have to multiply the numerator by 3. Final answer, 17/24. Now watch student B. So student B just multiplied these two together and said the common denominator was 48, which is a common denominator, not the least common denominator. Well, 6, I'd have to multiply by 8, so I'm going to multiply the top by 8. That's going to give me 40. 8, I'd have to multiply by 6, so that's going to give me a 6. 40 minus 6 is 34/48. So that's not the same thing. Well, it is. This is just needs to be reduced. And students will say, well, that's See, I can do that easy enough. 17 over 24, same answer. What you have to understand, though, is that we're going to progress to dealing with variables here, and if you don't reduce them in the beginning, it can lead to expressions here. They're going to be more complicated than just numbers that might be more challenging to reduce. It'll always be in your best interest to always try and determine the least common denominator instead of just any old common denominator. So I've got a couple examples to show you what I mean by that. All right, so if we look at these two fractions, so what you need to get your brain programmed, A and B are just taking the place of numbers. They have all the same properties, and we do everything the exact same. So if I wanted to get the common denominator of the letter A and the letter B, so I need something that both A and B would divide into. Well, that expression would just be the expression AB. A will divide into that, and B would also divide into that. Now it has to be A multiplied by B, not A plus B. Same thing over here. AB. A will divide into that, and B will divide into that. So you look at the first fraction, and you ask yourself, what would I have to multiply this denominator by, the letter A, in order for it to become AB? Well, I would have to multiply it by the letter B. So I'd have to multiply by B. So remember, whatever you multiply the denominator by, you must multiply the numerator by the same thing. So 2 times B would just be 2B. B, to become AB, I'd have to multiply by the letter A. Now, I'm just showing these kind of in the beginning. We're not going to do that all the time. We're just going to do that in our head. Then that means I got to multiply the numerator by the letter A. So 1 times A would give me A. Then the last thing you should do is write it as a single fraction. Once we get going, we'll probably do that all at once, but for now we'll kind of show you the separate fractions. So when you add two fractions that already have the same denominator, your answer will have the same denominator. 2b plus a are not like variables, not like terms. I cannot collect those together, so this just simply becomes 2b plus a over ab. That is a single fraction that would be the combination of those two fractions added together. Okay, so the second one now is an example to show you where students will incorrectly look at this and they'll say, oh, the common denominator is a to the fifth. So, well, it would work, but there's a lot smaller ones that would divide, that would be a common denominator instead of a to the fifth. I need some algebraic expression that both a squared and a to the third would divide evenly into, and I want the smallest possible. Well, the smallest possible one they both divide into is actually a to the exponent 3. As long as this exponent is smaller, it will always divide into higher powers of that same letter. So for example, a to the fifth would, anything below a to the fifth would divide evenly into a to the fifth. A to the seventh would not divide into a to the fifth because the exponent's bigger than what you're trying to make your common denominator. So in these two, the common denominator would be a to the exponent 3. A to the exponent 3. So now we're going to look at what I have to multiply each of these expressions by to turn them into this common denominator. So for example, a squared, I would multiply by the letter a, because when you multiply, you add exponents. So a squared times a to the 1. So that means that I have to multiply the numerator. Right? So this one, switch colors here. I have to multiply just by an a. That would give me a cubed. So that becomes 3a, because you always have to multiply the numerator by the same thing you multiply the denominator by to make your new denominator. A to the third, it's already a to the third. Perfect. Don't have to do anything to it. It just stays the way it is. Now I have a common denominator, so when you add or subtract fractions, denominator stays the same. These just get combined together. If they happen to be like terms or something, you would collect them, but they're not like terms. So we're just going to leave it as 3a subtract 2 over a to the power of 3. So that's kind of an introduction on where we're going with adding and subtracting rational expressions. So rational expressions, as you know, are just fractions that involve variables, like we ran into here. So let's just kind of put some of this into more formal context. I don't know why I have that twice. So we just did. So as we already mentioned, if you already have a common denominator, adding and subtracting is really easy. If I had 1/8 plus 3/8, the answer is 4/8. Now, one thing that you always have to do is you always have to check your answer to make sure it doesn't reduce any further. It's not if you feel like it, you have to always put your answers in reduced form. So 4/8 would reduce to 1/2. So it's no different when we're dealing with algebra. So if I took these two expressions and I look at them, notice the denominators. Oops, too far. The denominators are already the same. Okay, so if I look at this denominator here, it's over x squared subtract 2x subtract 8. If I look at this denominator, it's the exact same thing. So whether they're numbers, variables, a single term variable, multiple terms like this, a polynomial, it doesn't matter. As long as the denominators are the same, you are able to add and subtract those fractions. Well, they already have a common denominator, so I just write it out. X squared, take away 2x, take away 8. I've got x subtract 4 plus x plus 8. These would combine. X plus x would give me 2x. Negative 4 plus 8 is plus 4. And that gets us to here. So then this is where it draws upon your prior knowledge on rational expressions. The first thing we learned how to do was reduce fractions of this nature. And if you'll recall, the way you do that is factor everywhere possible. So this is, again, factoring is going to be a critical skill that you have. The numerator has a GCF of 2. Factor that out. 2 to 1 to x plus 2. The denominator factors. Multiply to get negative 8, add to get minus 2 would be x subtract 4 and x plus 2. Okay, well this x plus 2 will divide out this x plus 2. One in the numerator, one in the denominator, like we did before, leaving me with just this right here. 2 over x subtract 4. That would be your reduced final answer. So even though it had a common denominator in the beginning to get us going, I still had to reduce my fraction at the end to get down to here. Right? Okay, so continuing on, here's kind of just a set of guidelines as to how do you find the least common denominator when you're dealing with variables. So if you're looking at monomials, so just a bunch of variables, but there's no addition or subtraction mixed in there anywhere. All you look at is every single variable that shows up somewhere in the denominator. So imagine these are the bottoms of fractions. And I was looking at these two fractions, saying, oh, what's the least common denominator? Say, oh, there's an x and there's a y. Those are the only variables I see. So then your common denominator is going to have x and y in it. The exponent that's going to go in each of these will always be the highest one you see anywhere. So I see x to the 5th and x to the 3, so I'm going to go with x to the 5th, the highest one. So right here it says use the highest exponent. I see y squared, I see y to the 4th, we're going with y to the 4th as their least common denominator. If there's coefficients in front of them, numerical coefficients, meaning numbers, you do the numbers first, just like you would regular numeric fractions. So if these were, again, imagine these are the bottoms of fractions. Something over that one, something over that one, something over that one. And let's say we were trying to add these three fractions together. So what my first goal would be, what's the least common denominator? Start with your numerical coefficients, 6, 12, and 24. And try and find something that they would all divide evenly into. Well, that would be 24. I have an x, and an x squared. And again, it's different. You'll see in the next one. There's no addition or subtraction mixed in amongst these denominators. This strategy I'm showing you only works when there's no addition or subtraction mixed in the denominators. I don't mean these additions. I mean in here. If this had beside it x plus 6, this is now a different type of x than these ones because it's got that plus beside it. That's coming in the next demonstration. So I said I've got x, and x squared. So the highest power I see of x anywhere in the denominators is squared. That would be the power of x. I see a y. The only one, that means the highest power then is that one right there. So I would need a y. So my least common denominator would be 24x squared y. Now, then what you would get into, these aren't actual questions, you'd say, what do I got to multiply this by to turn it into the new denominator? Well, you'd have to multiply by 4, you'd have to multiply by x, and you'd have to multiply by y. So you'd have to multiply this expression by 4xy to turn it into that. So you'd multiply the numerator by 4xy. This one, 12xy, to become this, you'd have to multiply by 2, by an x, and that would be it because you already have the y. So you'd have to multiply this one by 2x. 24x squared. Well, you have 24 and x squared. Well, I have 24x squared. The only thing I don't have here is the y. So all I would have to multiply this one by would be y over y. Both the numerator and denominator always get multiplied by the same thing. We mentioned that earlier. And then the final scenario we're going to run into is when you have polynomial denominators. So imagine that these were your denominators. Oops. And these two fractions are added. And I was trying to figure out the least common denominator of these. The first thing, this is critical, when you have polynomial denominators, these are considered monomials. But when you get into polynomials, which means they're separated by addition and subtraction down in the denominators, the first thing you must do is factor. The factors of x squared plus 4x minus 12 are these two. The factors of x squared plus 2x minus 8 are these two. Now, you're going to look these denominators over, and you're going to treat them just like they are a single variable. So if I look here, when I look at these denominators, every factor that shows up here in anywhere in these denominators would have to show up in the new common denominator. I'm definitely going to need an x subtract 2. Got that. I'm going to need an x plus 6. Got that one. I'm going to need an x plus 4. Got that one. X minus 2. I don't need to put it down because I already have it. It duplicated itself from over in the first one. So when you're doing questions like this, that's what you'd love to have happen. A factor you get here, it's always nice to get one over here because then that simplifies your least common denominator, makes your work easier. You'll see as we get into those. But that's basically the way it works with monomials. You factor, and then every factor that shows up in your denominators has to show up in your least common denominator as well. So if you looked over those 4, you would see 1, 2, 3, those 3. X minus 2 get duplicated, so you only put it once because they would both divide into x minus 2, this one and this one. Why you only needed the once. If it had exponents on it, you might run into this a little bit, not too much. But let's say you had a squared here on this one. That was squared. Well, then that would mean that you'd need a squared here. It's like the same thing as having an a. Remember we had a and a squared. The rule is you take the highest power. So if they are binomials, so instead of a, so this one, you'd use a squared as your common denominator. Well, if you had 1 over x plus 3 plus 1 over x plus 3 squared, you would use x plus 3, the highest power. That would be the common denominator of those two fractions. What students do wrong is they take and just multiply these together. And I shouldn't say wrong. They complicate their lives. If you were to take and multiply these two together and put x plus 3 cubed as your common denominator, it could work, but it's going to generate an expression up here that's going to be perhaps very difficult to simplify. So having in the back of your mind you're going to have to reduce these fractions, you want to make that step as easy as possible. And the way that becomes as easy as possible is if you use the least common denominator, not just any old common denominator. All right, so let's get to work and looking at, first of all, if I had some fractions, and we'll find the least common denominator. So if I had 16 over 3 on x plus 2, and then 4 over 3x, and I was trying to get the least common denominator. Well, this 3 is a factor 3. So is this 3. If this had been 3 plus x, then it's two different things because then it's a term versus a factor. See this x here? This x is a term x. And so what's the difference? See how this x is x plus 2? These two things are separated by addition. That makes this a term and this a term. But versus this x, it's 3 multiplied by x. They're right beside each other, no adding or subtracting between them. This is considered a factor x, which is different than a term x. So if I'm looking at these, I'm going to need a 3 and a 3, so we're going to need 3. I'm going to need an x as a factor because there's an x over here, and I'm going to need an x plus 2 to cover that binomial. So my least common denominator would be 3x multiplied by x plus 2 if I had those two fractions added or subtracted. See how we did? Now these are typically multiple choice, but I didn't want you to see the right answer. I couldn't get rid of the check mark, so this would be your right answer down here. All right, let's look at the next one. I've got 5x, x, and x plus 5. So if I was trying to identify the least common denominator, again, and they strategically gave you numbers here to try and make sure you really understand what you're doing. This 5 and this 5 are different. This is a factor 5, this is a term 5 because they're separated by that, x plus 5. So this one, your common denominator, you're going to need a 5x. That'll cover this. The x here will cover this x because they're both factors x, so that's fine. And then I'm going to need a binomial x plus 5 to cover the bottom of this one. Now, students will say, well, can't the 5 and the x that I used here cover the 5 and the x here? No, because these are factors, 5 and x. These are terms, x and 5. They do not cover each other. So our least common denominator for that one, we should be good. Let's just double check. 5x onto x plus 5. Good. Next one. So I've got x onto x minus 4. X squared take away 2x minus 8. So anywhere we've done anything with rational expressions, the first thing you should always do is factor. This one does factor. It's x take away 4 and x plus 2. So now if you looked at these two fractions, this one and this one, you need all of those factors from the denominators of these ones covered in your least common denominator. So we're going to need an x to cover that. We're going to need an x take away 4 to cover that. X take away 4 we already got, so we don't need to put it down again, and x plus 2. So this would be your least common denominator of all of those. X from there, x minus 4 we already had, and then x plus 2. All right, so I've got x squared onto x plus 3, and then an x plus 3. So this one is where we look at, I have an x, and I have an x squared. They're both factors because this x squared is multiplied by this. That makes that a factor. This is a factor. The rule is take the highest power. So we're going to need an x squared. That's going to cover this one and this one. We're going to need an x plus 3. That will cover this factor. It'll also cover this factor. So therefore, that should do it. X squared onto x plus 3 would cover all of those as a least common denominator. They'd all divide evenly into it. So we'll check our answer. X squared onto x plus 3. All right, one more. So this one's got some more factoring in it. Let's factor it. So the denominator of this one would be x plus 6 times x plus 6. So that's x plus 6 squared. This one is difference of squares. X take away 6, x plus 6. Let's start with the x plus 6. So you see here we got x plus 6 squared. We also have an x plus 6 over here. So that's comparable to when you have like a, where we do that one. This one here, we had an x and an x squared. It's the same with binomials. I've got x plus 6 squared and x plus 6. So something that both of those would divide into would be x plus 6 squared. And then I'm going to need an x subtract 6 to cover this factor. Even though it doesn't show up here, that doesn't matter. Every factor that appears in the denominators must be part of your least common denominator. That would cover all of those denominators. X plus 6 squared multiplied by x minus 6. All right, so now that we see how to find common denominators, hopefully, let's put that into practice and let's add and subtract some fractions. Now this one's all done out for us, so we'll just kind of walk our way through and talk and look at it. So I've got 3a squared b as one denominator, and I've got 6ab to the fourth as my other denominator. Start with, when there's numbers, so these are all monomials. There's no adding or subtracting mixed in the denominators. Start with your coefficients, 3 and 6. And you say, what would they both divide evenly into? 6. A squared and a. The rule is take the highest power. That's why there's an a squared. B and b to the fourth. So the highest power of the variable b is b to the fourth. So now we're going to make our new fractions. So that we want both of these to now be over 6a squared b to the fourth. I want you to look at their work, what they did. They took this fraction, 3a squared b, and they multiplied by 2b cubed. Well, the reason they did that is because, well, in order for 3 to become your new common denominator, which was, scroll down a bit. I find sometimes this line will confuse students. This is where you're trying to get to. You want them both to be over 6a squared b to the fourth. 6a squared b to the fourth, least common denominator. Look at this one, 3a squared b, and say, what do I need to multiply that by to turn it into that? I'll start with the number in front. The number in front, the numerical coefficient, it's 3. I want it to be 6. So I definitely got to multiply by 2. I have a squared. I want a squared, so I'm not going to multiply by anything. That one's good. I have b, but I want b to the fourth. So in order for b to become b to the fourth, I'd have to multiply by b to the third. So whatever you multiply the denominator by, that's why they're multiplying here by 2b to the third. Look at the next one. I have 6ab to the fourth. I want this as my new denominator. 6 is already good, so don't multiply that by anything. I have a, but I want a squared, so I got to multiply it by an a. So I have to multiply this by a. So I got my a squared. B to the fourth, it's already b to the fourth. So the only thing that I had to multiply that denominator by to turn it into my new denominator was just an a. So that's why they multiplied both the numerator and denominator by a. As I said, usually we won't show this. We just kind of talk about it and do it in our heads. And we'd arrive here. So then now I've got common denominators. So then you group the two together. Okay, so like so. That would be an answer. But this would be equivalent to you telling me the answer to a question is 10 over 20. I'd say, oh, good, that's great work, but you're not gonna stop there, are you? And then she'll say, oh, yeah, right, I have to reduce it. It's the same with algebraic ones, rational expressions. This is great, lots of good stuff to get to here, but you can't leave it like that. That's equivalent to leaving your answer like this. You're going to reduce it. Factor the numerator. Well, there's a GCF. You could take out a 2, an A, and a b. So 2ab would be a greatest common factor in the numerator. Well, then this fraction out in front will now reduce. 2 over 6 reduces to a third. A over a squared. Again, we did this back when we did reducing or simplifying rational expressions. So that would give you an a left in the denominator. And that would also give you a b cubed in the denominator, because you're going to, this b would cross out one of the ones from here. This a would cross out one of the ones from here. And the big thing to understand is you're only allowed to do that when they are factors, not terms. So you couldn't go here and say, oh, let's cross out the b to the fourth and the b to the third because of that addition stuck in the middle. The difference is, well, how's it different here? The difference is now I've got this multiplied by this. So the first part here, that would be a factor. And then this whole thing would be a factor. So when I reduce all that, 2 over 6 went down to 3. A over a squared left me with an a in the bottom. B over b to the fourth left me with b to the third in the bottom. And then nothing happened to this, so it just stayed there. There's your final reduced solution. Okay, so let's start to finish do a few of these on our own. I have 3a cubed over 2b. So I want these to get a common denominator. Start with your numbers in front, your coefficients. Well, you say, well, 3 and 2. What will 3 and 2 both divide into? 6 and 6. I have a cubed and b. So that means I'm going to need a cubed b. A cubed b. So the next part now is ask yourself, what do I have to multiply this by to turn it into this? And whatever that number is, you have to multiply. So your original numerator, you have to multiply it by whatever you have to multiply this by to make this. So I'm going to have to multiply by 2. Good with that, right? 3 times 2 will give me my 6. A cubed. I have a cubed, so I'm not going to do anything with that. But there's no b here, and I want there to be a b. So I'd have to multiply by 2b. So leave your 5a for now. And now I got to figure out what I'm going to multiply this numerator by. I have 2b, and I need it to become this. So I got to multiply by 3. 2 times 3 would get me my 6. I'm going to have to multiply by, I don't have any a's at all here, so I'm going to have to multiply by a cubed. I have b, and I want b, so that's good. So that's what I'd have to multiply that denominator by to turn it into my new least common denominator. Let's see what we've got. So 2 times 2b, so that's 4b over 6a cubed b. Yeah, that's 3. Minus 5 times 3 is 15. A times a to the third is a to the fourth over 6a cubed b. So now I've got two fractions, same denominator. We can combine those together as one fraction. So just subtract these. They're not like terms, so it's just going to be 4b minus 15a to the fourth divided by 6a cubed b. That's your denominator of your fraction. Now the good news this time is this numerator does not factor any further. So my answer is reduced. So that's in reduced form. Final answer. All right, let's go to this one. 3a and 5a squared. So my new denominator for each of these, 3 and 5 would divide into 15. I have an a and an a squared. Remember the rule? Take the highest power, a squared. So your original, a plus 4. Now we got to figure out what we're going to multiply it by. And your 2a minus 1, we need to figure out what we're going to multiply that one by. Okay, so 3a, I want it to become 15a squared. I'm going to have to multiply by 5a. 5a times 3a, that would give me my 15a squared. 5a squared, I want it to become 15a squared. I'm just going to have to multiply it by 3. 3 times 5a squared would give me that. And remember, whatever you multiply the denominator by to make that, you have to multiply the numerator by the same thing. Well, if it's like this one, notice how I put it in brackets because the 5a has to multiply by both of these. So this is going to become 5a squared plus 20a over 15a squared. 3 times both of these, so 6a minus 3 over 15a squared. Now I've got two fractions with the same denominators, so I can combine all of this stuff up here. So it's going to be 5a squared, 5a squared plus 20a plus 6a minus 3, and then it'll all have the same denominator now, 15a squared. Let's see the numerator, if there's any simplifying we can do. These two will combine, so I've got 5a squared plus 26a, take away 3, everything will be over 15a squared. Now, this is a hard trinomial, but I don't believe it'll factor any further. So if it doesn't factor any further, it doesn't reduce. 5 multiplied by negative 3 is negative 15. Yeah, there's no way we're going to multiply to get negative 15 and add the same two numbers and get 26 in the middle. So we know we are done. That's our reduced answer for those two fractions added together. All right, so what if the denominators are not monomials? Those last two examples, three examples, I guess, all had monomial denominators. So now, all of a sudden, there's addition and subtraction mixed in the denominators. Well, the rule is factor anywhere possible first. So we'll start with the first one, which is really quite easy. I look these over, they don't factor, they're already factored. Perfect. So then, write this as, I need every factor that shows up in these denominators must show up in your least common denominator. So we're going to need an x take away 2, and we're going to need an x plus 8. That covers this factor and this denominator. Take away. This one's going to be the same. X take away 2 multiplied by x plus 8. So this first fraction, which is over x minus 2, I want it to be over x minus 2 times x plus 8. So you say, well, what would I have to multiply that by to turn it into that? Well, I have to multiply by x plus 8. That means I have to multiply the numerator by x plus 8. I have x plus 8, but I want this as my new denominator, which means I'm going to have to multiply that denominator by x take away 2, which means I have to multiply the numerator by x take away 2. So now I'm going to expand this out, 2x plus 16. Don't expand these denominators, don't multiply them together, leave them as factors. Oops. Now, I know that can be, so why are you multiplying the top? I'm multiplying the top because I know I'm going to group those all together. The denominators are not going to change. I don't want to touch those. I want them to be factors so that maybe I'll cross one of them out later on. So subtract 5x minus 10 over x minus 2 on x plus 8. Now I have the same denominator. One big fraction. X minus 2, x plus 8 is the denominator of that new fraction. And now we're going to combine these. Now, here's the one thing you got to watch for that catches many students. The numerators of fractions, even when there's no brackets, are assumed to be in brackets. Now you may be saying, big deal, why? See the subtract sign? It goes here, but it also goes all the way over to this one. So when I go to write this out in the denominator, I'm going to get 2x plus 16, take away 5x. Usually once students get the hang of this, everybody gets these ones right. It's this next one they get wrong. This negative distributes onto here because of these implied brackets. They don't have to be written there. Negative, that's really plus 10. Now I'm going to combine those all together. I've got 2x, take away 5x, so negative 3x, 16 plus 10 plus 26. Nothing happens in your denominator. Again, notice I'm not multiplying it out. Leave it as factors. And good news, this doesn't factor any further, which means this fraction is already in reduced form. Okay. So always start by factoring. When you've got multiple termed expressions in the denominator, you're going to factor. So again, reinforces the need to be competent at your factoring. Difference of squares. X subtract 4, x plus 4. Multiply to get 16, add to give 8. Well, that would be 4 times 4. So you're going to get x plus 4 squared. All right, least common denominator. I'm going to start at this point. Once students kind of get the hang of this, what I'd like to start doing is kind of skipping from here down to here. And the way you do that is you go right to one big fraction. Instead of putting, like I did here, two separate ones like this, just put one big line and go right to your single fraction, because that's what you end up doing at the end. So my single fraction, I'm going to need x minus 4. I have x plus 4, and I have x plus 4 squared. So remember, when you have the same factor, repeat it, the rule is take the highest exponent. So we're going to need x plus 4 squared. Okay, look at this denominator. Ask yourself, what would I have to multiply this by to generate this? Oops. Well, I have the x minus 4. I have x plus 4, but I want x plus 4 squared. That means I'm going to have to multiply it by another x plus 4. That would get me to add the exponents, right? If you have x plus 4 and you multiply it by another x plus 4, that's the same thing as x plus 4 squared. So whatever I did to this, to make this, I must multiply the numerator by the same thing. I have x plus 4 squared, that'll cover this, but I need an x minus 4. So that means, that means this numerator is going to have to get multiplied by x subtract 4. Because if you multiply this denominator, x plus 4 squared, by x take away 4, you'll get that. Whatever you multiply the denominator by to get your new common denominator, you have to multiply the numerator by the same thing. All right, let's expand. I've got 4x plus 16 plus 3x, take away 12, put our denominator back in. 4x plus 3x, 7x, 16 take away 12, is a plus 4. Okay, we're getting off fairly lucky with most of these because when we get to this last part here where we've combined everything and tidied up all the like terms, this is not factorable to go any further. So that tells you that your fraction is reduced. So we're done. That one's reduced. All right, so let's have a look, and I got a couple more examples. I think I just have a couple here. Yeah, a couple more here, and we'll then let you try and do some practice of these. So I've got these three fractions, a combination now of adding and subtracting. So I'm going to show you like I did before. I'm going to go right away to my new common denominator as one big denominator. So I have a w. This is a factor w. It's the only one. I'm going to need a factor w. I'm going to need a w subtract 1. So this is a factor, this whole thing is a factor, and this whole thing is a factor. So I'm going to need w from there, w subtract 1 from there, and w plus 2 from this one. So the first fraction is over w, but the new denominator is all of these three multiplied together. So in order for that denominator to become this, I would have to multiply what's already up there, 2, by the ones that I'm missing. So I'm missing the w minus 1 times w plus 2. If you multiply those two by that, you'd get that. That's why I got to multiply the numerator by those two factors. Look at your next one. I have w minus 1. That covers that one. But I don't have either of these two factors as part of that denominator. So I have to multiply that by w and w plus 2. So w and w plus 2. And then plus 2. So I've got w plus 2, but I don't have this factor w and this factor w minus 1. So I'm going to multiply by w and w minus 1. All right, so now I got to do some expanding. I'm going to multiply the two binomials together first, and then I'll multiply my answer by 2. But you could multiply in here by 2, get your answer, and then multiply by that, whatever you prefer. So I'm going to go 2, w times w, w times plus 2, plus 2w, negative 1 times w is negative w, and then negative 1 times 2 is a minus 2. Take away 3w times w, take away 3w times 2, negative 6w, positive 2w times w, let's do 2w squared, a positive 2w times a minus 1 is a minus 2w. Put your denominator back in there, w take away 1, w plus 2. I got to multiply each of these by 2, so I got 2w squared plus 4w, take away 2w, take away 4, take away 3w squared, take away 6w, plus 2w, oops, minus 2w, up here, still all over w minus 1, w plus 2. And now we're going to collect like terms. 2w squared, take away 3w squared, negative w squared. 4w, take away 2w, that's 2w. Take away 6w, that's a negative 4w. I forgot to square. Let me try that again here. 4w, take away 2w, that's 2w. take away 6w, that's a negative 4w, and then take away 2 more w, that's going to be minus 6w. Numbers now. I got a negative 4, and that's it. So take away 4 all over w minus 1, w plus 2. This polynomial here, it won't factor. It has a negative in front of the w squared, but I could take the negative 1 out. But even if I did, there's no way you're going to multiply to get 4 and add to get 6. So that doesn't factor any further. Now let's just take this example. We'll give ourselves a bit more room to work on this one. That. And we want to, okay. This one's got some factoring I'd have to do first. So let's factor this first. So it's 4, w minus 2, w plus 2. Take away 2 over w plus 2. So the least common denominator of these two fractions would be w subtract 2 multiplied by w plus 2. I need, sorry, not w, y minus 2, y plus 2. I need a y plus 2, but I already have that. It was repeated over here, so you don't have to put it down again. There's your common denominator. The first fraction, which is already over these two, you don't have to do a thing to it. Leave it as it is. This second fraction is over y plus 2, but I want it to be over y plus 2 multiplied by y minus 2. So the numerator here, you're going to have to multiply it by that missing factor, y minus 2. That's what I'd have to multiply this denominator by to make it become this. Now multiply this into here, so you've got 4, take away 2y plus 4, y take away 2, y subtract 2, y plus 2, still your denominator. I've got 8 minus 2y, 8 minus 2y over y subtract 2 over y plus 2. So this is the first time now in many examples where the numerator, so this would be an answer, but it's not the reduced answer. The numerator will factor. So we got to factor that numerator out, see if that does anything for us. There's a GCF of 2 in the numerator. So factor out the 2. And we're going to get 4 minus y over y take away 2, y plus 2. So even though we did factor that out, it still doesn't reduce any further. This 2, so students, why don't you cross this 2 out with this 2? Because this is a term 2. You can only cross out the whole factor, not a piece of the factor. This would be a factor 2, but there's no factor 2 down here. So there's nothing that I could cross out to make this reduce any further. This would be our simplified version of our answer. Okay, let's do a couple more with some factoring. Yeah, let's have a look at these two. And then these should be good to get us going. Okay, so I'm going to take the first one, x plus 2, and I'm going to factor it, the denominator. So multiply to get 5, add to get minus 6 would be x take away 5, x take away 1. Multiply to get negative 35, add to give a plus 2. So these are simple trinomials because they have 1s in front of them. So they should be hopefully relatively easy for you to factor. X plus 7, x take away 5. Let's build our common denominator. So I want all the possible factors so that these two denominators will divide evenly into whatever we choose down here. X minus 5 will cover that one and that one. X take away 1 covers that one. X plus 7. So these three factors would be considered the least common denominator. Okay, look at the first fraction. Right now it's only over these two. I want this fraction to now be over these three, which means I'd have to multiply by the one I'm missing. I don't have x plus 7. So the numerator of this one, x plus 2, would have to get multiplied by x plus 7 because I had to multiply the bottom by x plus 7 to turn it into that. This one is over x plus 7 multiplied by x minus 5. X minus 5 and x plus 7, but it doesn't have this factor in the denominator. So that means I'd have to multiply the bottom by x take away 1, which means I'd have to multiply the top by x take away 1. Expand, x squared plus 7x plus 2x plus 14. Take away 5x. Careful here, it's negative multiplied by negative, so now plus 5. Put your denominators back in. X take away 5, x take away 1, and x plus 7. Clean up the numerator and see what we've got here. X squared plus 7 plus 2, so that's 9. Take away 5, so plus 4x. 14 and 5, so plus 19 over x minus 5, x take away 1, and x plus 7. This is a simple trinomial, but 19, there's no way to multiply to get 19 except 19 times 1. So there's no way to multiply to get 19 and add to get 4. There's your reduced answer. So that's those two fractions subtracted. Our last one. So this one is over, same thing, you got to do some factoring here first. So I get 2x, multiply to get negative 12 and add to get 4. X plus 6, x subtract 2. GCF, take out x squared and also a 5. So 5x squared is the greatest common factor, leaving me with x squared, take away 4. And actually, this will factor even further. Did I do that right? Yep. So 2x over x plus 6, x subtract 2, plus 3, 5x squared, x take away 2, x plus 2. Difference of squares on that. All right. Let's see what we got here for our common denominator. So remember, every factor you see in the denominators here must be accounted for in our least common denominator. I always like to do monomials first. I'll get what I mean by that is the 5x squared here, that's a monomial, it doesn't have a plus or minus stuck in between it. Let's start with that. We're going to need 5x squared. Put that out in front. Then I like to go kind of left to right. I'm going to need an x plus 6. And I'm going to need an x minus 2. 5x squared I've got. X minus 2 I've got. X plus 2 I don't have. So all of these factors will make up the denominator of our new fraction. Now, look at each one separately. X plus 6, x minus 2. What do I need to multiply that by to turn it into this? Well, x plus 6 and x minus 2 I've got. I'm going to have to multiply by 5x squared and x plus 2. So 2x is going to have to get multiplied by 5x squared times x plus 2. This denominator, I have 5x squared, I got that. I've got x minus 2, I got that. I got x plus 2, got that. The only factor I'd have to multiply this by, turn it into this, would be x plus 6. So that means I have to multiply the numerator by x plus 6. All right, let's expand this numerator and clean it up and see where it takes us. So we've got, I'm going to multiply the two monomials first. I got 10x squared, no, x cubed. I got to add exponents, x squared, x to the 1. That's going to then get multiplied by x plus 2. I've got 3x plus 18. Write your denominator back in here. 5x squared, x plus 6, x take away 2, x plus 2. Multiply these two together. I've got 10x to the 4th plus 20x cubed plus 3x plus 18 all over. Just keep writing your denominator. And there you have your final answer of those fractions. added together. Now, so how do you know? Well, I know that this is something that we're not going to be able to factor, so this doesn't factor any further. So yeah, it's not simple. So it's none of our factoring strategies that we've learned. So therefore, that would be our final answer. And yeah, they get kind of ugly looking, some of these answers, compared to what we're used to seeing. So that's why we kind of wait and do addition, subtraction after multiplication and division, just because it's a little bit more work to do these because of the whole having to get common denominators, just like it is with numeric fractions. Multiplying and dividing, you don't need common denominators to multiply and divide fractions, but you do need common denominators when you go to add and subtract fractions. All right, so that is how to add and subtract rational expressions. So at this point, we're going to make sure you do a little bit of practice on these, which are found in your textbook, page 336 to 339. Those following questions we'll go through, and again, the answers are all in the back. So this will be a mixture of monomial denominators as well as polynomial denominators. And it's a really good practice, again, to give you more exposure to practicing your factoring skills, which are kind of the primary skill set to have in this section if you're going to be successful. All right, thank you for watching.